So hi everyone, I'm Cadet Carl Steven F. Kaime, and today I'm gonna show you the manual plotting of collision avoidance. So we have a problem here. Your ship's course is 080 degrees through with a speed of 18 knots. At 10:1500, the lookout reported a ship with a bearing of 0 to 0 degrees in the distance of 9 nautical miles. So the same ship was seen after 6 minutes on bearing 0 to 1 degrees through at a distance of 8 nautical miles. So first thing, you're gonna plot your initial course, which is the 080 degrees through. So here, get your triangular ruler and then measure 080 degrees through. And then label it 080 degrees through and speed of 18 knots. So next is plot your first target's position. So first target is 20. It has a bearing of 20 degrees through. 20. And then range of 9 nautical miles. So get your compass divider, measure 9 nautical miles from the distance scale. We'll be using the 12 miles distance scale. So 9 and transfer it to the bearing of 20 degrees of bearing. So here, this is our first bearing. Label this one as R, and then the time of 1500 hours. The next, plot the second target's position. So which is 21, bearing of 21 and 8. So 2 4 6 8. So here, and then the next thing you'll do here is label this second plotted position as M. So point M, and then the time. So we will be just plus 6 minutes to 10:1500. So the time would be 10:2100. And the next is we're gonna plot our RML, which is the relative motion line. So in doing that, you're gonna connect point R to point M and extend the line to your ship's position. So here, point R to point M, and then label this one as our RML. Then here, we're gonna find the DRM, or the direction of relative motion. So to do that, from your relative motion line, slide it to the that one to your ship's position. So here, and draw a relative line to get your DRM. So read this. We are gonna read this line, which is, this is 190, then it touches the 191. So our DRM is 191 degrees through. The next, we're gonna find the SRM, or the speed of relative motion. So we'll be using the DST formula, which is D S is equal to D over time. So in finding the distance, this is the distance from R to M, and then for the time, this is the time interval. So S is distance from R to M. Measure this one, the use of your compass divider. So and here, so this is 1 nautical mile, 1.2 1 nautical mile. So 1 nautical mile, so 1.0 nautical mile over time interval of 6 minutes. Then convert your 6 minutes to hours. And doing that is gonna do 6 divided by 60, so it's 0.1. So 1.0 divided by 0.1 is 10 knots. So we have our SRM, and the next is finding our the CPA of the target. So CPA, so CPA, from your relative motion line, you can get the CPA relative motion line, and you will measure 90 degrees from your relative motion line to your ship's position. So here, as you can see, this is our relative motion line. So here, so this is 90 degrees. So we're gonna find your CPA distance. So the CPA distance, with the use of compass divider, measure this RML to your ship's course to get your CPA. Transfer it here. So it would be 1.5. So 1.5. So the CPA distance is 1.5 nautical miles. The next is we're gonna find the bearing of the CPA. So bearing of the CPA, from your relative motion line, extend this line and read the so here, so this line, extend this one. So your bearing of CPA, or the BCPA, is 101 degrees true. And the next, we're gonna find the time of CPA. So time TCPA. So in getting the TCPA, we're gonna use the DST formula. So time equals distance times speed over speed. So from distance, this is the measure of R to your CPA. And then for your speed, this is the SRM. So here, time equals, so from point R to your CPA, you're gonna measure that one. So use your compass divider from point R to your CPA, and then transfer it to the distance scale. So it's 9 nautical mile. It's 9 nautical mile. So 9. So from point R to CPA, is 9 nautical mile. So 9 over SRM of 10 knots. So get your calculator. So 9 over 10 is equal to so 9 over 10 is equal to 0.9. So since this is R in an R, you gotta convert this to minutes. So times 60 times 60 is equal to 54 minutes. So here, 54 minutes. So from point R to your CPA, we have the 54 minutes. Then you can add this 54 minutes to the time of 10:21. So 10:21 plus 10 plus 0054, then minus 1060 to its 11 15 100 is your TCPA. The next, we're gonna get our 5. We're gonna get our ship stroke course in speed. So first, TT, TTC, and TTS. So first, we're gonna find our ships through speed with formula of DST. So DST, distance over time. So from this distance, we're gonna measure E to M. So in getting E to M, from your course, ship's course of 0 degrees, connect that relative to point R. So from point, so from this course, slide that one to point R relative to your point R. So that, so here you have to locate the point. To locate the point E, you will solve for the distance, which is D is equal to speed times time. So here it's from your speed is 20 knots, 80 knots times your time interval 0.1 is equal to 1.8 times 0.1 1.18 knots. 18 knots times 0.1 is 1.8 nautical miles. So 1.8 nautical miles is the distance from, this is the distance from E to R. E to R. So measure 1.8 nautical miles here. 1.8 1.8998. So here 1.8 from your R. Label that 1.E, and then connect E to M, the use of your rectangular ruler. So we have completed our vector triangle. So if we measure this E to M, no, it's exactly 1.8. So we go back to our target stroke course, which is distance from E to M, distance from E to M over the time interval. It is 1.8 over 0.1. Then calculate that 1.8 over 0.1 is 80 knots for your ship's through speed. Then for your ship's through course here, from this angle, E to M, you just slide that one to your ship's position. So from E to M, slide that to your ship's position. So E to M. So this will be our ship's through course. So read that one, it's 291. So our ship's through course is 291 degrees through. So that's it. We have completed our problem. We have the RM, the SRM. Next is the CPA distance, the bearing of CPA, the time of CPA, target stroke course, and target stroke speed. So that's how you will solve the collision avoidance in manual plotting of radar plotting sheet. So thank you guys for watching, and God bless. Goodbye.